Good afternoon. Four, five, six, seven. 1, 2, 3, 4, 5, 6, 7. Yay! I'm all caught up on attendance. That's good. Okay, I just added something to the slides in case you previewed them, but we're doing it for warm up anyway because I just think that maybe we didn't discuss it enough. So we're gonna discuss that, which will help you all on your midterm, and then we will go through the regular slides that we had. So good job. Did anyone watch any of the videos I sent? Did they help? Okay, McKenna says yes. Elena's like, no, they did not. Maybe a little, but it's okay. And Kelsey, did they help a little bit? Okay. Elena, by the way, I'm not offended if you say they didn't help. Like, it doesn't bother me. Sometimes they help people, sometimes they don't. Some people have a very thin skin. I think you probably know. Maybe you're a thin-skinned person. I don't know. I'm not a thin-skinned person. You probably know that about me by now. So I just want to do what's helpful to you. And if I give you something and it's not helpful, then I would love to know that. Because, by the way, I've been thinking about this. So I know you have a lot on your plate with midterms, but think about this. If you would be interested in helping me with this at all, I think it's for points, McKenna. I think it would say it doesn't count for a grade, but I'm pretty sure I made it count for a grade in this one. So, nice, Tyler. Yes, you can leave that off. I hope your midterm is not today. Let me look. No, yours is tomorrow, Tyler. So I hope you feel better tomorrow. So, yep, just type in the chat if you have any questions. You'll be fine. Was I think so? Yes, the more review is for points. I was talking about people with thin skin. Sometimes, have you ever met a person with a really thin skin and then you feel bad because you insulted them and you didn't even know you insulted them? Yeah. So, and teachers kind of have to have a thicker skin. You might have heard that already, right? Yeah. So, but it's okay. As anyone who's worked in customer service before, you need to have a thick skin, right? So if you've worked in retail, if you've ever made phone calls, anything like that, yeah, then you have to have a thick skin. So it's not just teachers. It's a lot of industries you have to have a thick skin for. What you need to remember is you shouldn't take it personally. Some people are just having a bad day and they just take it out on you, right? So when I ask for feedback on assignments, I'm never going to take it out on you. Like if you say that assignment was not helpful to me, like it did not help me. So, and what I was starting to say was 256. Do you remember how many assignments were in 256? And you were crying. Remember, there was just so many. Yeah. You're like, yeah, that was terrible. So, I need to thin those down, right? And I need to pick out which ones are important and helpful. And so, but I also need a student's perspective on that. So if anyone's interested in doing that with me, like after the semester ends, you know, I'd be grateful for your insight. So, and we could just do it virtually, you know, like through email or whatever. Like it wouldn't be that big of a deal. Tyler, was that you volunteering or did you have a question? Oh, yay. Okay, Tyler. So if anybody else, I'll send you guys an email that says if anybody's interested, and I'll send you a list of the assignments. Like we'll just go like week by week. and we'll see which ones you really thought were helpful and which ones you did not think were helpful, because that I want to make it, when I had more time and this was a 16-week course, it's easy to do more assignments, right? But in an 8-week course, I have to pick and choose very carefully what is helpful and what is not. And sometimes I've been teaching it too long, so I don't know what is helpful when you're learning it. So I need that feedback. And ask your students for feedback on their assignments as well when they do it, because it's very helpful. It's called being a reflective practitioner, right? And as a teacher, you always want to improve, especially when you teach in the K-8 environment, because sometimes you only get to teach that lesson once a year, right? You won't teach it again until a year later. Well, you're not going to remember what went well and what went poorly unless you have feedback from your students on it. So, and you don't have to do it daily on every assignment, but the bigger assignments, the assignments that you feel are really beneficial, make sure they really are to your students, because that's really important. I had the luck of teaching middle school, and some of you might teach middle school. So I taught like 3 of the same classes in a day. So maybe it was a little shaky in my first period class, but by the 3rd time I taught it, it was golden, right? It was so much better. I knew where students were going to get stuck. I knew where they might have questions. But as an elementary school teacher, you might only teach it once and not revisit it for a whole year. So think about how you can get feedback on those things. All right. So speaking of that, I was just telling them I changed my slides a little bit, and now I'm not even sure I still like them. So, but that's okay. Vanessa, is that you volunteering or a question?
I have a question.
I'm ready.
I got here when you were talking about more. Did you say that the more review was going to be worth points? Is that what
I think it is worth points. I mean,
Okay.
you can see it on there. I didn't look at it, but it says whether it counts towards your grade or it doesn't. And I'm pretty
Okay.
sure it just counts towards your grade. So, and when is it due?
I believe Friday. It's available until Friday.
Yeah.
I can double check right now.
Okay, what am I looking for? I need to be in the right class. That's step 1. Okay. Does not look like the right one. Oh, maybe because I was in week 3. Okay, so I added this right here because I just want to see if you have an idea. This should be real quick. Just think about it. Which measure of spread matches which measure of central tendency? And you might be like, I'm not sure I buy that. And then we'll talk about it more in just a second. So just take a quick look. All right, so just quickly, and this literally I just added, 5 minutes ago. So which measure of spread would you use with the mean? It's not a trick. Bethel, you were going to do it and then you didn't. Okay, Elena put it out there. Elena said MAD. How many of you agree that it would be the MAD or the standard deviation? Yeah, because it's called the mean absolute deviation. So it goes with the mean. Makes sense? So which one goes with the median?
Is it the IQR?
Yeah, it's the IQR, because think about a box and whisker plot. There's the median, and then the IQR shows you where the middle 50% of the data is, yeah? Now, this one's a little weird because the range you could show with any of them, but the range is kind of a loser measure of spread, right? It's really not effective. So what measure of spread do we use with the mode? Any ideas? Or what do you think about it? All right, I'll ask my question differently. When would you report the mode as the best measure of central tendency? When would it be most appropriate to use the mode as your measure of center?
For me, wouldn't it be when you do that frequency table?
Okay, it depends on what your data looks like, right? So you can do a frequency table, and maybe that's your goal, but do you see how, McKenna put it in the chat, when you have categorical data, if your data is categorical, like what's your favorite pet? What's your favorite ice cream? Right? Anything like that, you can't do the median or the mean of it, right? It doesn't make sense. Like, how do you find the middle of cookie dough and chocolate? I don't know, right? So when you have categorical data, the mode is the most appropriate. So now let's talk further. If the mode is the most appropriate, like in this situation with categorical data, what measure of spread can you do with categorical data? None, right? Like there is nothing. How are you going to measure the spread of ice cream? Like, what does that even mean? You know, so do you see how that was kind of a trick question? So usually when we're, first of all, we don't often use the mode as our measure of central tendency. So if we do, it's probably because it's categorical data, right? So if it's categorical data, we can't use a measure of spread. So usually we're talking about these situations right here, okay? And I think you guys know from watching your video that the mean is most appropriate when? When is the mean most appropriate? What type of data do you have when the mean is most appropriate?
When there's outliers?
The mean is best when they're outliers?
Oh, when you do not.
Oh, when you didn't have them. Wait, which is it? Is it because like you can
I
guess?
thought it's when you
50-50.
have outliers.
Okay, so let's talk about it. Would the mean be better when you have outliers or not as good when you have outliers? And let's think about what it's really doing.
It wouldn't
Go
be
ahead.
as well because the mean will be too high, so that's why I mix it up.
Yeah, the mean will either be skewed too high or too low given the information. So remember in that video, it said the mean is the most sensitive of the measures of central tendency, which means if your data is not close together or clustered around the mean, like you would know by looking at the MAD or the standard deviation, then you shouldn't use the mean. So when we do test scores, often in education, we use the median instead of the mean, because test scores, if somebody doesn't take the test, it can skew your data a great deal, right? So, or if somebody just bombs it, so you have to be careful. The median is fine when you have outliers, right? Because you just mark them off from the ends and you end up with the middle point. So oftentimes with test scores, we use the median. So an example of when the mean is really good, of the Olympics, right? when they do the Olympic time trials, all those, like for running or swimming, all of those times are so close together, right? They're not far apart at all. So the mean is very appropriate. And so when we do the mean, we'll use our mean absolute deviation or our standard deviation, right? Now, if you watched the videos that I sent yesterday, the mean absolute deviation and the standard deviation measure the same thing. They measure the average distance from the mean, okay? But they measure them using a different formula. And truthfully, like true statisticians as their profession would never use the mean absolute deviation. They would use the standard deviation. So why do we talk about the mean absolute deviation? Well, it's a precursor formula. It's an easier formula mathematically, okay? So, and it's a 6th grade standard. In 6th grade, they do that mean absolute deviation formula. So if you were like, this should not be on my midterm, it's too hard. It's a 6th grade math standard. So it's okay, you can do it, I promise you, okay? In high school statistics, that's when they use standard deviation. And if you watch those videos, the formulas are similar, right? You still subtract each data value. You subtract the mean from each data value. The difference is in mean absolute deviation, we take the absolute value to make them positive. In standard deviation, we square them to make them positive, okay? And in then we still add them all up and divide by how many data points there are. And then for our mean absolute deviation, that's our answer. For standard deviation, then we have to take the square root to bring that back down because we squared each of those, okay? So that's really, it's just a calculational difference. It's not a meaning difference, right? It's still measuring how spread out the data is from the mean. So I hope that helps. And if you haven't watched those videos yet, go ahead and watch them. I do examples from the housing conundrum of why would we use the median housing price instead of the mean housing price, okay? All right, so I did just find a website that has a great question and explanation on it, and I'm gonna put it in the chat for you. There's a video attached to it that might help you if you're struggling with the central tendency question. Okay, so there's the website, and it's question 1 on that. And there's a video attached to it too. So I didn't watch the video, but I previewed it and it looks good. Like I read the whole question and made sure they looked at that. Okay, so that being said, try this warm up. This is a fun one. Can you see my screen still? Thank goodness. Okay. The incubation time in days of a canary, dove, myna, pigeon, parakeet, raven, chicken, cockatoo, peafowl, turkey, swan, and muscovy duck are observed and the plot has been drawn. Read the plot, answer the question. So first of all, this box and whisker plot is missing a title, right? So it's missing a title. It's also missing whatever units they are. What do you think the units are? It says in the problem. So I would call this incubation time. And sometimes they put it up here in days, and sometimes they put it down here in days. All right, so now you should be able to answer that question, those 4 questions. So try that. And in the chat, put what you're having for dinner because I'm so hungry right now, okay? Or lunch if you didn't eat lunch yet, like me. All right, I feel like I've gotten lots of answers and I'm getting very hungry. I didn't get to answer all of you about what you're sending me that you're eating. If you're not quite finished, it's okay. No worries. Let's talk about it. So, what's the median? And it says interpret it in context of this problem. So, anyone want to try that one? It's great midterm oral practice, right?
I said 20.5 only because I could see that the line is between 20 and 21. So I'm guessing it's 20.5.
Anyone agree with Bethel?
I was confused as to do 20 or 21 because that's why I was like,
So did some of you put 20, some of you put 21, and
I put
Bethel
20.
20.5? Okay. Actually, the key to this, because I took this from something else, is 20.5, by the way. So good job, Bethel. So, but if you put 20 or if you put 21, because on the computer screen, sometimes you can't tell, I would have accepted any of those answers. Okay, 20, 20.5, or 21. Okay, so that's first of all. Then second of all, who wants to try interpret this in the context of the problem? This is the part that would be on the oral midterm, right?
So if I had to interpret it based on the question, it would take approximately on average 20.5 days for a bird of all the types that are on the question to incubate in the egg and then hatch.
Do you guys agree with what Elena just said? Anyone have a different interpretation? I agree with what Elena said, by the way, but you could interpret it a little bit differently. How about half of the incubation times of these birds is less than 20 and a half days, and half of the birds it's longer than 20 and a half days? Do you agree with that context? So do you agree that they were both correct? Yeah. So how Elena said it, the average incubation time is 20 and a half days. That's true, right? Or you could say half of the birds incubate in less than 20 and a half days, the other half in more than 20 and a half days. Yeah? Makes sense? Not too bad? Okay. What percent of the animals are above or incubate in longer than 28 days?
And I don't know if I'm right, but I said 25% are above 28 days.
Anyone agree with Betty? A couple of you. Some of you are like stone-faced. I don't know if you're trying to practice your poker face for the oral midterm or what's happening. So, but yeah, so this would be 25% because here's 28 right here. 28 would be Q3, right? And so 25% of the animal incubate in longer than 28 days. Okay? Questions on that? Okay. An animal that has an incubation time of 16 days is in what percentile? You're like, we didn't talk about percentiles yet. But some of you watched the video. What do you think?
I'm gonna shoot it. The 25th percentile.
Anyone agree with Bethel? Jessica does. Betty does. Essay does. Oh, very nice. Karina does. Yep. The 25th percentile. Because that's Q1. Okay, so that's the 25th percentile. Yes? Okay. So if we try to interpret the 25th percentile more, depending on if you watched our video or not yet, you could say what that means is it incubates longer than 25% of the other birds, or it incubates in less than 75% of the birds, in less time than 75% of the birds. Okay, what's the IQR for this data set and what does it mean? What's the IQR for this data set and what does it mean? Who wants to try that one?
I said that the IQR was 12, and that means that 50% of the like animals that were incubated were within 50% of each other.
What do you think of what Amanda said? This was a hard worded one, right? The wording is challenging on this one. I like what Amanda said. So Q3 minus Q1. So we did 28 minus 16 and got 12, right? So this IQR is 12. So 50% of the birds incubate within 12 days of each other. Yeah, or have an incubation time within 12 days of each other. And those days happen to be between 16 days and 28 days. Does that make sense? Any questions on that?
I have a question.
I'm ready, Betty.
I'm still kind of confused on how to explain what it means. I know how to do the IQR, but I mean, I heard what you said, but I don't know, it's still confusing.
Okay, so do you see where we get 50% of the data?
It's between Q1 and Q3.
Right, so
And
the
they're each
middle
25.
50% of the data is in the IQR, right?
Mhm.
So you could say most, right? Because 50% would be most, right? Or close, or you could say half, right? So half of the birds incubate within 12 days of each other, have an incubation time within 12 days of each other, because that's my IQR, that 12.
Okay, that makes sense now.
Does that help?
Yeah, thank you.
Okay, so was this a helpful activity, what we just did? Yeah? It's going to start you on the road to percentiles, right? Because percentiles are related to where our box and whisker plots are, right? And because we have this, the median would be the 50th percentile. The Q3 would be the 75th percentile. This would be the 25th percentile. Now, by the way, there's no 100th percentile. Do we all know this? The highest you could be is in the 99th percentile. We don't talk about the 100th percent, like there's no way to get there. In case you ever had a standardized test score and you were like, oh, I'm in the 99th percentile. That's the highest it goes. They don't say you're in the 100th percentile. That's not a thing, okay? Okay, so let's talk types of distributions, yeah? So distributions can be described by their socks.
Did you freeze again?
I would love to be described by my socks most of the time. Am I frozen? Okay, are we better now? Okay, good. I stopped talking because I could tell everybody, either I was frozen or everybody was frozen because none of you were moving. So I think we're better now. Okay, good. So distribution are described by their socks. And in socks, what we talk about, we're talking about the shape of the distribution, the outliers, the center, and the spread. So the shape is exactly what you think of, what it looks like, maybe if I do a dot plot or if I do a histogram, what it looks like. So we'll look at those in just a second. Outliers, we've kind of talked about, but not super specifically yet, right? So we kind of generalize what is an outlier, right? An outlier is a data point that's far away from the rest of the data points. There is a mathematical way to judge outliers. So outliers, you can say beyond 2 standard deviations, would be an outlier. Okay, that's what they usually say. Beyond 2 standard deviations is an outlier, which will make more sense in just a minute. Now, you could replace standard deviation with mean absolute deviation just because that's the measure we're talking about right now. Or you could say beyond 1.5 times the IQR. So do you see how that would give you a different measure, right? So it depends, are you using the mean or are you using the median? If you're using the mean, you would say it's beyond 2 standard deviations. If you're using the median to judge if it's an outlier or not, you would say it's beyond 1.5 times the IQR. Okay? That's how we could quantify outliers. Okay, center, we talked about that, right? What's the best measure of center? That's mean, median, or mode. And then spread. And for spread, we have range, IQR, MAD, and standard deviation. Okay, so we want to use all these things together to describe a distribution, right? We don't want to use just one of them, right? We definitely want to use more than one of them. Sometimes we don't have to discuss outliers because there are none, right? Okay, everybody okay with that? Okay, we could have symmetric distributions or we could have skewed distributions. So symmetric distributions are bell-shaped or uniform. Skewed distributions, sometimes people get these confused. So it's where the tail goes. So if the tail extends to the right, it's called right skewed. If the tail extends to the left, it's called left skewed. Some people miss those up in their brain because they seem counterintuitive. They seem backwards to some people. I don't ask a lot of questions about these, if any, but it's kind of nice to be aware of it. These are the distributions we like the best right here. These bell-shaped distributions, those are our favorite, right? They help us the most. Okay. So a normal distribution is a very specific distribution. And normal distributions are when we use standardized testing and things like that. So usually you hope that your population is a normal or approximates a normal distribution because you can do so much more with a normal distribution than you can a different kind of distribution. But the key is it's bell-shaped, so it's symmetric, about the mean. It has a single peak. The mean, the median, and the mode are all the same in a normal distribution. Interesting? So they're all the same. The mean, the median, and the mode are all the same in a normal distribution. Now, since it's symmetric and the mean, median, and mode are all the same, you can say that 50% of the data is below the mean and 50% of the data is above the mean, right? Because everything, 100% would be under the curve. Now, we can say 50% of the data is above the median and 50% of the data is below the median all the time, whether it's normal or not, right? So, but if it's normal, we can say that about the mean, and that means something different, right? Think about that, but the mean and median are the same in this case. Okay. Data values farther from the mean become increasingly rare. That would make sense. If your distribution looks like this, here's the mean right here in the middle. The further you get away from the mean, the fewer data values there are there. That makes sense. That's very logical to me. Okay, so the graph is bell-shaped, tapering tails. They never touch the horizontal axis. Okay? And then almost all of the data under a normal distribution is within 3 standard deviations of the mean. That means above or below the mean. So some of you are interested in special education, right, in this class? Who's doing special ed? Yep, a couple of you. They use normal distributions to evaluate whether students are eligible to receive services or not. Yes? So they will use these standard deviation criteria to determine if students are eligible for services. Sometimes it's beyond 2 standard deviations. Sometimes it's beyond 3 standard deviations before they're eligible for services, which is a shame because let's say you have, here's your, I'll show you on the next slide because it'll make more sense on the next one. Okay, so here's the empirical rule. If you have a normal distribution, right here in the middle, that's your mean, your median, and your mode, right? See how it says X bar? So that's your mean and your median and your mode. Okay. This first, this X bar plus X and this X bar minus X, that's within 1 standard deviation. Okay. So 68% of your data lies within 1 standard deviation if it's a normal curve. Okay. Then if you go out 2 standard deviations, right here, let me change that color. If we go out 2 standard deviations, we have 95% of our data. So remember how I said if it's an outlier, it might be considered beyond 2 standard deviations? Well, you can tell that's only 5% should be outside of there, right? 2.5 above and 2.5 below because it's symmetric. Okay? And then within 3 standard deviations, 99% of the data should be within 3 standard deviations. Now, you might have seen different numbers with these. You might see 68, 95, and 99.7, or you might see 67.8, 95 point something, and 99. So sometimes these numbers are a little bit different, but they're very, very close. Okay. So what I'm saying about special education is, let's say a student takes some kind of standardized test, right? And they test right here. This is where they are on your curve. Well, let's say your district says you don't get services unless you're beyond 3 standard deviations. That kid won't be eligible for services. Does that kid probably still need services? Yeah, they probably do. So that's where 504 plans came in. How many of you have heard of 504 plans, right? Instead of IEPs, we have 504s. So sometimes you can implement a 504 plan for a student so they can get services, even though they might not technically meet the criteria for an IEP. Okay. The same is true. What if you have a kid who's way up here? What kind of kid is that? That kid would be eligible for gifted education, right? So in gifted education, they have a percentile for that as well when they do their tests. Now they started doing some alternate testing too. So then some students who just didn't do well on that standardized test would still be eligible for gifted services as well. So think about that when you're teaching your classes. You know, you might have kids, that's why it's kind of nice to see percentile, right? When you see this kid right here, you don't go, oh my goodness, right? You just know where they are compared to their peers, and you know what services might help them. That's all, right? Same with the kid up here. You don't go, oh, but now maybe it explains some behavior in their class, right? Have you ever had that kid in your class that's off task all the time? Maybe you were that kid. There's usually a reason, right? So think about those things. Okay. Now, this talks about Z-scores. We don't really care a lot about Z-scores. If you took stats class, if you do your master's program, or if you took 1-4X, you probably did some Z-scores, right? I'm not worried about Z-scores for what we need to do. So you're fine, okay? So no worries about Z-scores. You might see them on more. I couldn't think of that word for a second. But if you look at Z-scores, I'll just write them in here. I don't think they're down here. No, they're not. Right here, if we put our Z-scores on here, this, if we have our z-scores, I'll write it in yellow so we can see z-scores. This would be 0, 1, 2, and 3, and this would be -1, -2, and -3. So z-scores standardize things to where if you have a z-score of 0, that's the same as the mean, right? So you scored the same as the mean. If you have a z-score of 1, that's 1 standard deviation above the mean. If you have a z-score of -2, that means it's 2 standard deviations below the mean. So z-scores, the only reason we made z-scores was so we could compare apples to oranges. For example, how many of you have heard of the ACT and the SAT? Yeah, those are different tests, right? But if I want to compare a student that got a 31 on the ACT compared to a student that got a 1220 on the SAT, I need to be able to standardize those. So I can do that by z-scores. But you don't have to worry about that, okay? I just wanted you to know that it exists. Okay, so in ours, this is 6th grade standards. They need to know histograms, dot plots, box plots, all of those things. But they also need, do you see right here, it says they need to be able to report observations, look at attributes and units of measurement. They need to give measures of center and variability, so interquartile range or mean absolute deviation. It's right there in your 6th grade standards, okay? And then describe any patterns, and then relating the choice of measure and center and variability to the shape of the distribution. So in other words, why'd you pick that measure of center, right? And that's what we've been talking about. That's the questions on your midterm. Okay. Deep breaths. I'm doing way too much talking. Sorry about that. Okay. Does this paper look familiar to anyone? Yeah. What is it?
The AIM scores, but I think it's the AZ Merit scores now.
Yeah, they're called AZ Merit. You probably remember getting these score reports at your house if you grew up in Arizona, right? Maybe they sent them to your house or maybe they came through the school. But it has this information on there where it talks about this is a language arts score. Then it has this, how you read it. And then it talks about whether you were proficient, highly proficient, partially proficient or not. This, by the way, isn't a real person. This is an example one for you. And you can get this off the Arizona Department of Education website. So it's really nice because and this comes with your kids' scores, right? It has an interpretation there for you. Okay, so assessments in education. Why do we do them? Why do we learn about statistics? Well, we try to measure effectiveness. How effective we are at measuring it, I'm not sure. Learning, student performance, etc. There are many types of assessments. How many of you have heard of benchmark assessments before? Nice. So benchmark assessments are usually normed assessments and they're regularly used in education. Who works at a school right now? Anyone? When do you give your benchmarks at your school, Betty?
Usually get them like in the beginning just to see where they're at, but also like midterm, you would say, just to see like if they learn anything at the end of a certain assessment or anything like that, just to see where they're at or if they're learning anything or anything like that.
Yeah, so there's usually one given right at the beginning of the year, right, as a benchmark. Sometimes, depending on your district, they'll give another one at like the winter break, right? Like right before winter break. And then they'll give another one in the spring, yeah? Some schools just do those 3, and it depends on which benchmark. We have a million benchmarks that we can give, right? In different subjects and everything. Then some districts give a monthly benchmark. Is anyone in a district that gives a monthly benchmark? Yeah, Bethel, monthly. Do you feel like it's overdoing it?
Not a little bit, because I would be the one performing it and I would really like hate it. But at the same time, I didn't think so, because then we knew like which kids were good in reading and math and which ones needed help or which ones would just like which kids to switch kind of.
Yeah. So some people say that monthly is too often. Some studies will show, nope, monthly is exactly what we need, right? So you can decide, and in your district, you'll have to see. It's just sometimes it's very time consuming, right? To do all of these and make those adjustments. So benchmark assessments are given periodically and they measure two things, right? Benchmarks will measure their ability, so how they score on the test, but it also gives them a rank or a percentile. So it compares them to their peers, yes? So those are two different things, two different numbers. So this is just an explanation. You can click that link to get more on assessments. Percentage and percentiles are similar but have different meanings, and both are super important in education. Here's a nice article if you're struggling with percentiles. Percentages tell you how well an individual performed on the test. For example, if a student took the test and got 34 out of 40 questions correct, you can say they earned an 85% on the test. You may be able to say, I don't know how well written your assessment was, that they know 85% of the material that's covered on that test, right? So that's measuring their knowledge, how much they know. Percentiles just give you an indication of how well that person did compared to other students. For example, you might have gotten a 34 out of 40 on a test, but compared to the others who have taken it, this was only the 60th percentile. Okay, so they did better than 60% of the students that took the same test when you look at the distribution of the data. That 60th percentile does not measure how much that student knows. It's just comparing them to their peers. Parents get very confused by this conversation. Yes, some teachers still get confused by this. So sometimes you'll get, I don't know if I have this question anywhere. Sorry, I'm just looking for it. Yeah, I have it down there, so we'll talk about it. But sometimes these tests come out and then you have parent-teacher conferences and your parents are freaked out and they just want to grill you about how their student is doing, and they're misinterpreting the percentile. So you have to make sure you understand clearly the differences so you can explain it to the parent, okay? And sometimes these are hard conversations to have because you will have students that are in the 10th percentile, right? So that's a harder conference to have with some parents. So just be careful, but you can't take that as your only measure, right? So, and I think in the video they discussed what's your population that you're measuring against, right? What are you measuring against? Is it all honors kids? Is it everybody in the nation? Is it everybody in your class? Is it everybody in your school? And you also have to understand that this is a moment in time. Students have bad days. We test them sometimes on bad days. Right now, they're doing lots of standardized testing, right now in school. And how many of you at your school, they send out messages, please make sure your kid gets a good breakfast and a good night's sleep, yeah, and a healthy lunch and all of these things, because we know that this is just a moment in time. So other things can affect our students. So what do you think of this question? Get this answer ready in the chat. What does it mean if a student is at the 60th percentile? But really, I want you to answer, why is this called a measure of location? Get your answer ready in the chat. All right, everybody have an answer? Let's hit enter in 3, 2, 1, go. And then I want you to read everybody. So it's going to take a minute because people type a lot. All right, so when you read through those, and you can vote for your own, I don't care, which one do you think described this the best in that this is a measure of location? And we have lots that are similar. So, but who do you think said it the best for you? I'm a fast reader, by the way. If you weren't done reading, it's okay. I'm a very fast reader. No one's voting for anyone else. Are you still reading? Oh, Maddie, McKenna's like, you guys are just making me feel so good, like I'm ready for my midterm. That's very soon, right? Okay, so the student scored better than 60% of the class. Sorry about my dog. Only 40% of the class did better than the student. It's called the measure of location because we are looking where the student is at academically compared to other students on this particular exam, right? Whatever this particular exam is. Jessica's, oh good, a lot of people like Jessica's too, another person who has their midterms today. Scoring 60% better than the class, also got a score that is above the class average. It's a measure of location because you need to know the median and the range of class scores to fully understand how the student is doing. Nice. I like Michaela's. It's the location where the student stands. Be careful, not knowledge. I mean, it is knowledge-wise, but just compare it to other students. So it's their rank. I like Amanda's is very specific. It tells us where in the data set the student's score is. So if you watch that video, I think she talks about lining everybody up, right, in a line. So it's your rank order. So good job. Yes, they're ranking. I think somebody else said that. Betty said it in hers. Excellent. Okay, so good job. Are you feeling a little bit better about the difference between percent and percentile? I hope. Okay, so here it is on a box and whisker plot, right? The 60th percentile would be about here because this is the 50th percentile and that's the 75th percentile. So about here-ish, right? If you were looking on the normal curve, if the data is normally distributed, the person would be right here at the 60th percentile, again, because the 50th percentile is right in the middle there, okay? Here's an example of benchmark testing. This is an RIT, map growth. So do you notice right here, the reason I wanted to show you this was this. So this is a student, let me see what it says. This is mathematics. Does it say what grade it is? Kindergarten. So this is math in kindergarten. And these are actual scores. I just redacted the student information. Look, do you see this? And do you see this? So this goes from fall of 18, then winter of 19, then spring of 19. Okay, and here's the student score. And then here's their RIT growth. This is a fascinating number to me as a statistician. This is what they're projecting. So they're using mathematical models to see how much growth the student should have. Did anyone have that teacher that before you took a benchmark test, they set a goal for you? Did anyone have that teacher? A couple of you are saying yes. I don't know what my feelings are about that. My son had it in 3rd grade. Now, I definitely know what my feelings were about a specific thing that the teacher did. The teacher had everyone's name on the bulletin board, maybe not their name, but it had a sticky note of what their score was and where they should be. And that, yes, thank you, Karina. It puts a lot of pressure on kids. If you are teaching students to learn and think and be problem solvers, you don't have to worry about that, right? They will be fine. If you're teaching them to be problem solvers and thinkers, you won't have to worry about that, okay? It's so funny. My kids went to a regular public elementary school, a great public elementary school. I loved it, but I always hated test time because about 3 weeks before the test, that's all we heard about, right? Standardized testing are coming up, don't take any vacations. And then like the whole week before, they practiced for the standardized test. And I hated it. I was like, I don't understand that. If they've been teaching you all year to think, we shouldn't be having this panic attack right before we take this test. So then my kids moved to a different school. And the new school's motto, it was a charter school, it is a charter school. The new school's motto was, we want our kids to love learning and be thinkers and problem solvers, and we hold them to very high expectations, right? So it was only my oldest who was there in 6th grade. And I knew it was standardized testing time because I was still had 3 in elementary school, right? So I knew it was standardized testing time, and the window is very small statewide, right? Everybody's giving them. So I asked my 6th grader, because I hadn't seen anything coming home. This is a brand new school to us. Hadn't seen anything about standardized testings coming up. Don't take vacations. Make sure your kid eats breakfast. I didn't see any of that. And then my son came home and I said, hey, have you heard anything about standardized testing? And he's like, oh yeah, we took it today. We took one of them today. And I was like, what? And I'm like, did you guys review for it? Or did you? And they're like, no. And it was such a different approach that I loved it, because when the teachers gave it to the students, the teachers just said, you know this, you guys got this, right? You are prepared. I teach you to think every day. I give you very taxing problems every day on a regular basis. I'm not going to teach to the test, right? Because you know this material. So, nice. Jessica saying, I liked how my past teachers explained these tests. It's information for the school and for the teachers, and we shouldn't be worried about it and just try our best. Oh my gosh, McKenna. A teacher told us you would get paid more if we scored higher. Lots of pressure on us. I wish they just explained it like yours did, Jessica. Me too, Jessica. So, and did both of you go to school in Arizona?
I
McKenna
was
did.
born and raised in Wisconsin.
Okay,
So I took Wisconsin standard tests.
Okay. Anyone else have a similar situation to either McKenna or Jessica? Amanda, you're saying yes. Was it same McKenna? Okay, how about you, Amanda? Was it like McKenna's or Jessica's?
It was like McKenna's. They would say like, oh, the better you do, the better of a bonus we get.
I am so disappointed by this. It is so sad. Oh, and Brianna says it's okay. It's in New Mexico, same thing. The funding for our school weighs on this test, so please do well. That's insane to me. Yeah, so be really aware of how you felt as a student. I'm not saying all your students will feel the same as you, but be aware of that when you go in there, right? So by the way, if we're looking at this score that I have right here of this student, what are your thoughts? If you're the teacher and you see this particular student's information on this. This is a math kindergarten score. What do you think? Tell me your thoughts. Anything at all.
I would be pretty proud of this student
Why?
because you could see from the beginning, from fall, they got 149 or a percentile of 72, and you could see as they increase with each of the test scores. Instead of
Yeah.
slowing down, they increase, and then a big boost from winter to spring. So
Yeah, and that's really nice, right? Yeah, as time went by, it increased. That's excellent. And does this seem normal? Does this seem like you should expect that? Like when they start in the fall, their score should be low or lower. And then by the middle of the year, they should have learned something, you hope. And then by the end of the year, that should go up. Yeah. So I like that. I'm fascinated by that projection score as well. Here's another one, just so you know, I'm not all about only math. They do measure reading as well. So this is reading, and this is also in kinder. Okay. And you can see there's our numbers again. Very nice growth, right? So, but it's nice to see these things and see how they're interpreted. Now, this is nice also to see. So here we have a bar graph. And the reason I called it a bar graph is because this bar and this bar and this bar are one person, right? This is the student. Then the orange is the district. And then the yellow is the norm grade level. So that's probably like normed in the nation, right? So that's what that is. So this student, by the way, is pretty good, right? Yeah, because they're higher than the district grade level mean and higher than the normed mean.
I have a question on this.
Yeah.
So in the beginning, when we were doing our like warm up, you had said like the mean because of outliers for like tests, you usually use the median. Why did they choose to use the mean?
Remember, this is normed. So this is a normal distribution. So the mean and the median are equivalent. Great question. Great question, Amanda. Yeah, so, and that, like, I'm talking on a regular test, like a test I wrote, not a test that's nationally normed. So these are nationally normed tests. So that's why. Great question, Amanda. I love that. Any other questions about this? I feel like as a student who's going to be a teacher, it's nice to see these scores and understand them. Did you ever look at your scores when you were a kid? Or did you just give them to your parents and walk away?
I did.
Okay, so you've looked at them, so you understand them a little bit, right? Yeah, I looked at my kids, and you know, all my kids would come on the same day, all of their reports on the same day, and then they would want to look at each other's, and I was like, no, that's not a thing. You're not going to look at each other's. You can look at your own, and you can ask me questions, but you're not going to look at each other's. It's none of your business, right? That's also why they send them to your house instead of at school usually, because kids will compare to each other, and that's nobody's business, right? Okay, here's an 8th grade student. You know I'm partial to 8th grade. So this is math. See what sense you can make of this. Can you see the percentile bands? Okay, somebody make some observation for me. Tell me what you think of this. Yeah, they did pretty good. I agree. They did pretty good. Because notice that in winter of 16, right, they start here in the orange which is 21st to 40th percentile. And then they continue now in fall of 18, they're in this blue, the 81st to 100th percentile. It's pretty awesome, right? Yeah, that's pretty awesome. Now, I'm fascinated by this. I want to know how they do this projected score, but that's just me as a weird mathematician. I want to know how that's happening. And you can see average achievement and then the district's grade level mean. But notice that this student's line is much higher than average achievement, right? So, but these different visuals, that's why we've been studying data displays as well as these measures, so we understand how to read these things. Here is it in table form. So you can see this student is 85th above the mean. Do you see that? Achievement above the mean, 85th. So they're in that 85th percentile right there. And then they have some other numbers for them, but I really like this. So when you see this from a student, does this mean they know 85% of the math material in 8th grade? Is that what that means? No. It just means they are in the 85th percentile. So they scored higher than 85% of the students that took this test. Okay. So as you can imagine, let's say a student comes in to their parent comes into parent-teacher conference and says, my student's in the 68th percentile, that's a D. How do they only know 68% of the material in 8th grade math? Do you see how that's confusing for parents? And that's not what it means. Because, and you'll explain it, no, that's not what it means. Your student actually did fairly well. If average was 50th percentile, your student's in the 68th percentile, scoring higher than 68% of the students. And then the parent says, but that's a D. So do you see the frustration? You have to be very careful. So yeah, it's not a D. It's not a D, right? Okay. Here's just more explanation. So I'm going to stop right here because I think some of you might have questions, concerns. I'm so sorry I talked this whole class, but I was stressed that some of you were panicked about percentiles for the test. And I wanted to make sure we figured out the when we use those different measures of central tendency. So questions.
Quick question. I believe when you started to mention about the oral exams, you mentioned question 7. Is that the question that we're going to be given, or is that the question you want us to start with?
You will start with question 7.
Okay.
You will explain that one, and then I roll a dice for the other 3.
Okay.
It's so fun. It's like probability, right? So I want you to think right now, which one do you not want to come up? It's just as likely as all the other ones, so be careful, right? Other questions?
For the home spreadsheet assignment, the second one, for some reason my Google spreadsheet had an update and I can't find the bar graphs anywhere. Every time I press chart, it automatically gives me a column chart and I can't change it to a bar graph.
If you have to submit a column one, just submit the column one.
Okay.
Google does so many updates, it's hard to stay current with them, right? So it's okay. If I figure it out, I'll let you know. Okay, I put your exit ticket in the chat. What other questions do you have? I'll stick around. I normally keep you late, and I feel like you have stress enough with midterms and everything that I'll just chill a little bit and actually let you out on time. Maybe even 5 minutes early. Wouldn't that be amazing?
I have a question about the oral exam. I can't remember, do we normally submit our work upload as well for that, or just the Canvas portion?
Just the Canvas portion.
Okay.
Yep.
Sounds good.
So just be prepared when you come to share your screen, or if you have a poster or a whiteboard or whatever. So, and have that uploaded in advance, you know, to your device so you can share your screen so it's not time consuming. Because some of you have waited for me before because my appointment before has run too long. Yeah, so if you have that all prepared, it will be faster.
Okay. Thank you.
And then remember, our final exam won't be at all about data analysis or statistics or probability. It will all be on geometry. So once you're finished with this midterm, you can set this aside because we're going to open something new. We're going to do our geometry units. Nice. Okay. Have you guys noticed how crazy windy it is outside? Yeah, like insanely windy. So if you
gonna be
have done
some-
your exit ticket, you're good to go. Otherwise, I'll see you in your midterm and tomorrow. Bye.
Roxanne, I had a quick question about just like what we were doing today. What is, because I know some people, because you opened up the final tonight. I mean, not the final, the midterm Canvas portion tonight, right? So what would be like questions from like normal distribution, since we kind of briefly went over it, but like not to, like, would it just be able to like label it, or what kind of questions would be on there about it?
Did you look at my midterm review? Because I think that's where I list what the questions are. Let me look.
I think I took, but I just can't remember if I saw like a lot of questions on it.
I don't think if I have any, I don't think I have any, but let me look. I'm looking right
Oh.
now. I'm looking right now. Midterm review. Sorry, it's at the very bottom. I'm just scrolling. Okay, so one. Nope.
Oh,
It's not
okay.
on there.
So this was just for our knowledge.
Yep.
Perfect. Okay, now I feel a little less stressed.
Yeah, so if you go to the very bottom of the midterm review, it says like there's one, find these statistics, you know, there's one, interpret central tendency, there's one, odds in favor, there's four, identify and interpret data displays, probability with a spinner, probability with cards, question on central tendency, spread, coins, tree diagrams, which data display, and probability from letters. So
Okay.
that's it.
Yeah, I looked at it. I just couldn't remember if this was on there. So thank you for the thank you for the refresher.
Yeah,
All right,
no
that was my
worries.
question. Good luck on your exams, guys. I know some of you have it, McKenna. Good luck.
She's gonna do great.
I have a question. So I got the exit ticket wrong. So can you explain, because I selected you scored 83 better than the rest of the people who took the test, but it said that you scored the correct answer, you scored better than 83% of the people who took the test.
Okay, so read the two statements again and tell me the difference between them.
So the one that's correct says better than 83% of the people who took the test. And the
And
one
what
that
does the other one say?
83 better than the rest of the people who took the test.
You see how you did not score 83% better. You scored better than 83%. If you say you scored 83% better, then I would take your score, multiply it by 83%, and then add those two together.
Oh, okay, that makes sense.
Yeah, so it's really, and the reason I did this exit ticket was because when I gave this midterm before, I had lots of people say that the person scored this much, this percent better, and that's not mathematically accurate. It's better than 83%. You see, it seems minor, but mathematically it's not a minor difference.
Okay, that makes sense. Thank you.
Okay, yeah, good. Kelsey, Betty, do you have any questions? Oh, okay. Yeah, no worries.
I'll probably email you later on today though.
Okay.
Yeah, but thank you.
Yep.